It's extremely useful for our research. So following the Montecito event and having noticed that these narrow cold frontal rain bands were associated with some of California's other flash flooding and debris flow events, we wanted to improve our knowledge of how well models were able to simulate these features. So we had this narrow cold frontal rain band on February 2nd of 2019 that moved across the Southern California Bight. And we ran a 3-kilometer simulation with the weather research and forecast model for this event. And the control configuration of the model, shown here, adequately simulated the presence and orientation of the NCFR. So on the left-hand side, we have what was observed by radar, this with the red areas indicating very high intensity precipitation along this band. And this is the model simulation. So on the right-hand side. And so it's, so the model simulation is adequately representing the presence and orientation of it, but misses some of the detail you see in the observations, that detailed gap in core structure. And the model produced the NCFR about an hour later than it was actually observed. And not shown here, we ran an ensemble for this with 21 members, and I'm just showing the control member here, so there's 20 other members in this ensemble, also produced an NCFR, but they were variations in the structure, timing, intensity, and orientation. And this was an event where we flew that atmospheric river reconnaissance I talked about earlier in the presentation, and thus had detailed observations on each side of the cold front of this narrow cold frontal rain band when it was still offshore of Southern California. And so we were able to compare the dropsondes to the dropsonde observations to model output, both ahead of and behind the cold front, so on each side of these bands. And so the observations from the dropsondes on the cold sides, this would be the eastern side of, or sorry, the western side of the cold front of the cold front, and the red line would be on the eastern side of the cold front. And so we're able to compare the dropsonde observations, which are these solid lines, to what the model simulated. And here I'm just showing vapor flux as one variable. We look at several variables here. And you can see, so you can see that the ensemble mean, the mean of all the ensemble members from the model, pretty adequately represents the vertical vapor flux. It does a little bit better on the cold side of the storm of the front, and a little worse, a little more spread on the warm side of the front. But generally our findings from this study, and you can see for the other variables in the paper referenced here, that the WRF model does well in representing some of the key physical processes associated with these narrow cold frontal rain bands that have been observed in previous studies and in theory, even if the resultant NCFR in each ensemble was different in timing, location, and intensity. And we need to expand this work to a larger sample size beyond this one event that we examined in this paper, and also do more work on assessing the performance of operational forecast models with these features. So I want to show an example of where alert data was really useful to solve a scientific question around some landslides that occurred in April of this year. So the story is, we're moving now to, we're looking at San Diego County, and we had a case of a slow-moving cutoff low pressure system impacting Southern California, which was accompanied by a weak atmospheric river. And so this low pressure system stalled out over Southern California during the first week or so of April, and kept recirculating moisture into the area over a 7-day period. And this period of persistent rainfall in early April of 2020 was about 400% of normal precipitation and record setting at some locations in Southern California, as you can see in the figure on the bottom right there. And near the end of the rainfall event, on the last day, April 10th, numerous damaging landslides were observed in an isolated area of northern San Diego County, in and around the city of Encinitas. And including this one on the far left at San Dieguito Tennis club, which was estimated at about 300,000 in damages. So our question was, you can see in the image on the bottom right, abundant rainfall fell across this region, so why were the landslides in such an isolated area around the city of Encinitas? And we were able to use alert gauge data and radar observations to help figure that out. So we examined several coastal and low elevation gauges in San Diego County and to help avoid any terrain bias. And on the left, on the top, we're looking at storm accumulation, 7-day precipitation accumulation for 6 gauges in the area. And on the bottom, we're looking at 15-minute precipitation observations for the 6 stations in the area. And the image on the right-hand side shows the gauge locations. They're a little bit difficult to see. They blend in with the background, which is the radar reflectivity at the time of the landslide event, but they're represented by the little donut circles. And then landslide locations are represented by black triangles, and under the Encinitas gauge location, there's actually quite a few landslides right in there that are all black triangles overlapping each other. And on the left, you should note that many of the gauges have similar accumulations for this week up until April 10th. And then at the Encinitas gauge in red, we have this burst of high intensity precipitation. And this isn't represented anywhere else in the 7-day time series at even gauges very close by or anywhere else we looked in the area. And so looking at the radar reflectivity, which doesn't show up well here because the landslides are superimposed above it, but we see that there was very high intensity rainfall, an isolated thunderstorm in the wake of this cutoff low pressure system, as can happen when the surface is warm, there's very cold air aloft and plentiful moisture. And so the landslides observed were clustered around where the Encinitas gauge was and this thunderstorm was. And the timing of the landslides observed matches up with the thunderstorm. And so the persistent rainfall associated with the 7 days or so the cutoff low was impacting the area, and the weak atmospheric river set the stage for the landslides by increasing soil moisture. And then this intense burst of rainfall at the end of the storm initiated the slope failure. And so the point of all this is to say that understanding the meteorology of these events helps to inform the geomorphology and associated hazards in the past, present, and future, and how we can focus our efforts on forecasting and early warning of these events. And so I want to wrap up with one more study that just came online this past week that we're really excited about. It's a similar storyline to what happened with the San Diego event, but in a very different location in the Sierra foothills. And so in this case, we had over 500 shallow landslides in a focused area of the Tuolumne River Canyon that generated more sediment in 1 day than the river would normally transport in 1 year. And this event also caused damage to parts of San Francisco's water delivery system downstream of Hetch Hetchy. And in this case, we had a strong atmospheric river that served to saturate soils and increase soil moisture for a roughly 24 to 30 hour period. And this atmospheric river was followed by a band of high intensity rainfall, another one of these narrow cold frontal rain bands similar to the February 2nd event I showed and the event causing the Montecito debris flow. And it stalled out over the area and produced very high intensity rainfall, which triggered the landslides you see on the left. And again, this is another case of how understanding these sequences of events from the meteorological perspective can improve our understanding of landscape evolution and hazard initiation. And I just wanted to get this one in here, so in case you all are interested in checking out the paper. And so I want to wrap up just summarizing what I talked about. We are at CW3E applying novel techniques such as machine learning, aircraft reconnaissance, and identifying these knowledge gaps, things like aerosols that may affect forecasts, to improve atmospheric river and precipitation forecasts for the Western US. I shared the atmospheric river scale that helps distinguish between mostly hazardous and mostly beneficial atmospheric river events. However, in the Western US, many of our impactful rainfall events are associated with short duration, high intensity precipitation. Those aren't necessarily going to be tied to atmospheric river strength. We have finer scale features driving those. And so we're working towards understanding the drivers of these features and how to better forecast them. And I just want to mention thank you all who operate the alert networks. These observation networks are really a critical piece of our studies for these high intensity rainfall events. And I'll thank you. There's our Twitter handle and my email if you'd like to send any questions, or if you're interested in any of the getting the link to any of the publications I've shared. Thank you very much. And I'll take a look at the questions, but Ron, you can determine where we're at on time. And
thank you so much, Nia. Yeah, we are doing good. So if you want to take a look, we've got a few questions there, so we can answer those live.
Okay, let's see. We've got, let's see. Let's see. Is there an available schedule for, so I will, Ellen Fox asked, is there an available schedule of field observation periods for particular storms within 24 to 48 hours of their expected landfall? So once the atmospheric river reconnaissance is up and running for the winter season, which will be January through March is what's planned, there's a tab on the Center for Western Weather and Water Extremes website where you can look and see what projects are going on. Our dropsondes and their locations also appear if anyone's familiar with the Tropical Tidbits forecasting site. You'll also be able to see the guy who runs that site maintains a list of all aircraft reconnaissance missions. He's more focused on hurricanes, but he'll also include, you'll be able to see the flight tracks for our flights as well. So a couple of places to get information about the reconnaissance missions as they're going. Let's see, hopefully that answered that question. Next question was, are you looking at cloud seeding? Our group is not working on cloud seeding at all. There is a group I came to UCSD from the Desert Research Institute. There is a group there at the Desert Research Institute that is working on cloud seeding. I'd suggest getting in touch with them and asking questions about cloud seeding. And if you want to reach out to me, I'm happy to make that connection. Let's see. And our longer one here, I'll go with the short one. Are the dropsondes recoverable? I don't know if they are or if they float. I'm actually not sure. I don't think that they are. They transmit as they're falling. So I don't know the answer to that. And Alan Fox asked, regarding the Encinitas high-intensity rainfall event, I would suggest that the eddies downstream from San Clemente Island may have induced bands of post-frontal thunderstorms. The weak atmospheric river left sufficient moisture, which could have been entrained into the thunderstorm band to induce the heavy rainfall. Yes, that is quite possible, and we've definitely seen convergence associated with flow around the Channel Islands, leading to enhanced convection is a commonly discussed thing. So I think I got most of them.
Yeah.
I'll turn it back over to you, Ron. And feel free to email me with any other questions. I can get you, if I don't know the answer, I can connect you to the right person.
Great, thank you so much, Nia. Yeah, so there was one question as well. Yes, the attendees actually don't see the questions until they are answered. So if they're answered live, we'll reread them just as Nina did. And If they're typed questions, you can go to the answered questions and see that, like Alan had responded to the questions from his presentation. So